Today we're going to be covering face, vertex, edge, and cross sections. So this is going to be a new unit. We're actually moving into unit 8. So this is just going to be the first section over it. Since we are dealing in geometry and you can see that there's a bunch of shapes that are going to be happening, I would highly recommend downloading this guided notes that I created, just because it has all the pictures and everything else that you'll need for these notes kind of laid out for you. So make sure you make a copy of this. So let's get started. So make sure that this is written at the top of your paper. And the first thing we're going to do is go over vocabulary. So there's 3 vocabulary words that we're going to be using. Make sure that you know what these are. So when I'm asking you how many edges or how many vertexes, you're able to tell me a no. So if you look over here, we've got our edge. So that's going to be the sides where it kind of turns from face to face. And those faces are those flat sides. The vertex is the corner. So face is the flat surface of a figure. So if you're thinking of a cereal box, it's where all the pictures are. The edge is formed by 2 faces of the 3-dimensional figure sharing the side. It's going to be where it turns over, like this part right here. And like I said before, the vertex is the corner. So it's a point where 3 or more edges meet. And that's going to be an important definition later on when we're dealing with other shapes. So 3 or more edges have to meet for it to be considered a vertex. So if you look at this, we've got an edge here, an edge there, and our third edge is there to make that vertex or that corner. First thing we're going to cover is naming figures. So I know that you've done this a lot in the past, so this is just a reminder to this. There's a couple of different words that I see here. The first 2 words that I'm going to highlight are the prism and the pyramid. So the difference between a prism and a pyramid is a prism has 2 faces that are exactly opposite of each other. So think of like a cereal box or a pop can or something like that. A pyramid comes to a point. And so there's going to be a point up top, and that's going to make that into a pyramid. So when I'm looking at this shape here, I automatically know it's a pyramid because it has that point up top. So I know it's not going to be A, it's not going to be C, it's not a cylinder because it does not have a circular base. A cylinder is like a pop can, so it does not have that circular base, so it cannot be a cylinder. Again, it does not have a circular base, so it can't be a cone. So it's either going to be a triangular pyramid or a rectangular pyramid. The difference between those two is the base. The base is the bottom where the shape sits. So the shape is sitting on this base right here. If we just look at that shape, that 2-dimensional shape that's flat, it looks like a rectangle. So it's going to be a rectangular pyramid. And that's our shape's name. This one should be an easy one. We've got a base that's a circle, and it's got another base up top, and those match up. So it's going to be a cylinder. So that's going to be E. Go ahead and try to name this figure on your own, and I'll give you your answer after. Hopefully you realize that it came to a point, so it has to be a pyramid, and then you looked at the base where it sits and saw that's a triangle. So it's going to be a triangular pyramid. So it's going to be answer choice B, as in boy. Let's try another one. If I'm looking at this, I know that this is going to be a prism because the where it's sitting, it has something directly across from it. It doesn't come to a point up top. So it's either going to be a rectangular prism or a triangular prism. The 2 bases that are opposite of each other are rectangles, so it is a rectangular prism. The only thing that you have to be kind of cautious of when you're thinking about things being across from each other is when we're dealing with a triangular prism. So a lot of times they show triangular prisms laying flat, kind of like my drawing right here that's a little bit rough. But you have to think about what's directly across from each other. When I'm looking at this, it's the two triangles that are directly across from each other. That thing that it's laying on, this rectangle that it's laying on, doesn't have anything across from it because this top is going to be just an edge there. So you have to look at what's directly across from each other, and in this case, it's the triangles. And so this is what a triangular prism is going to look like. Let's move on to our next one. Most of the time, everybody can name this. Hopefully, you already have the name in your head, and it is a cone because it has that circular base and it comes to a point up top, like an ice cream cone. So now that we have finished naming our shapes and talking about how to name our shapes, I want you to think about the number of faces, vertices, and edges of these shapes here. So go ahead, draw them out if you need to. If you need to Google what this shape looks like, you can go ahead and do that too. For a cube, it's like a dice. So I'm going to do this one with you, and then I'm going to have you do the rest of these on your own. So can you figure out the relationship? So our final question, once we have this all figured out, is going to be, can you figure out a relationship between the number of faces, vertices, and edges of three-dimensional figures? So that's our goal by the end of this. So let's start off by figuring out how many faces, vertices, and edges a cube has. I made a drawing of a cube over here, so let's go ahead and use that. So the first thing that we're looking for is faces. Faces is the flat parts. So when I'm thinking of a cube, how many sides does it have? So hopefully that answer is a little bit easy. It has 6 sides or 6 faces because it's a 6-sided die. 1 on the top, bottom, and then 4 going around. Vertices are our corners. So we've got a corner here, 2, 3, 4. So there's 4 on the top. There's also 4 on the bottom. So 4 times 2 is going to give me 8. So there's 8 different vertices. Edges is a little bit tricky. It's really easy to lose track of them. So make sure that you are kind of drawing as you go along so you don't double count. So we've got 1, 2, 3. I'm going to do this. 1, 2, 3, 4. So there's 4 going around the top. There's 1, 2, 3, 4 going around the sides. And 1, 2, 3, 4 going on the bottom. So 4 times 3 is going to give me 12. And so that's going to be my answer for that one. So go ahead, think of a rectangular prism, a triangular prism, a triangular pyramid, square pyramid, pentagonal pyramid, and octagonal pyramid. Again, you can Google pictures of them if that's going to make your life easier. So go ahead, pause the video, and try that out. Hopefully you have this completed, so I'm going to reveal the answers. So double check to make sure that your chart matches my chart. So thinking about that relationship, if you look at these, we have 6 faces, 8 vertices, and 12 edges. See if you can see that relationship. So if you were to add the faces and the vertices together, and then you were to subtract 2 from that, you're going to get the number of edges. So try that out. 4 plus 4 gives me 8. 8 minus 2 gives me 6. And that's the number of edges. Try it out for a few more problems. And so it works every time. So technically, this is kind of going off of Euler's method. Euler's method says if we take the number of edges and we subtract faces plus vertices, we get 2. And so I like using this more simplified version to determine how many edges we have in our shape because, like I said before, it's really difficult to count edges. So if you remember that little trick, you're going to be able to count them easier because I know a lot of times this is what students miss on tests is figuring out how many edges there are just because they're more difficult to count. But you can also double check yourself. So if I'm asking you to find the faces, vertices, and edges, you can use this little formula here and make sure that it equals 2 at the end, and you have a good idea that you did it correctly. So make sure that you copy that formula down so you can use it in the future. And there's that modified version of Euler's formula, faces plus vertices minus 2 equals our edges. Now we're going to move into cross sections. So cross sections is really easy for people that can picture things in their head and very difficult for people that cannot. So it's very hard for me to verbally explain this without showing you images and specifically images that move a little bit. So we're going to watch this video. I think it's like 2 minutes long. But they do a very good job of showing cross sections and kind of explaining that briefly. We'll go through and talk a little bit more about what's said in this video after. So just go ahead and put your pencil down and watch this short video.
Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
So hey, hopefully this video gave you a good introduction of what cross sections are. So let's go ahead and talk about it.
This video is a basic geometry review for those who are taking the SAT and the HT exam.
All right. So three-dimensional figures can be cut by planes. We talked about that a little bit in the video. So we're cutting it with planes. When you cut a three-dimensional with a plane, the result is a two-dimensional figure. And so when they were doing that in the video, they were talking about ellipses, they were talking about trapezoids. It also produces circles and rectangles and triangles. So basically all you need to know for 8th grade is horizontal and vertical cross sections. So horizontal being left to right, vertical is up and down. We rarely, if ever, give you a cross section that's diagonally cut. So to find the horizontal cross section, so left and right, so it's parallel to the base, it's going to look like the base, which makes sense because you're just shortening the height of it. So it's going to look just like the base. If you cut it up and down, the cross section is going to look like the lateral face, which is what the side looks like. So if you're cutting a square pyramid, the sides are triangles, so it's going to be a triangle. If you're cutting a cylinder, that's when it gets a little bit weird because it's, a smooth side. There is no lateral face. So if you just think about it being cut up and down, let me draw a picture real quick. So we've got a cylinder drawn in green. The cross section vertically or up and down is going to actually be a rectangle. So some of these things you either have to draw them out to kind of see them or just memorize them. So when we're looking at a cone, for example, if we're doing the horizontal cross section, it's going to be whatever the base is. So the base of this cone is a circle, so the horizontal cross section is also a circle. I want you to think about what a vertical cross section would be though. This one's a little bit tricky because again, there's no lateral face, the face on the side. So you have to kind of picture that drawing of what that would look like. So do that now. Hopefully you saw that it looks a little, let's do it bigger. There we go. Hopefully you see it looks a little bit like that, which looks an awful lot like a triangle because it is a triangle. So the vertical cross section of a cone is going to produce a triangle. So we already did talk about the horizontal and vertical cross sections of a cylinder. So hopefully you remember that. If you forgot, it is a circle for the horizontal cross section because again, it goes parallel to the base. For the vertical cross section, it's going to end up being a rectangle because when we slice those sides, you're just connecting them and it makes a rectangle like that. So I want you to go ahead and try this vertical and horizontal cross section. Whenever we do a vertical cross section, we always go to the top for that. So think about what that's going to be. And so the vertical cross section is going to be a triangle and the horizontal cross section is also a triangle for this one. So I want you to try these two 100% on your own and double check your answers with me after. So I've done the vertical cross sections in red and I did the horizontal cross sections in green. So for this one, both of them are actually squares because the lateral face are rectangles because the lateral face is a rectangle for the vertical cross section and the base is a rectangle for the horizontal cross section. For our rectangular pyramid over here, our horizontal cross section matches up with the base. So since it's a rectangular pyramid, the cross section is a rectangle. And our vertical cross section, you can see is going to end up being a triangle because that matches up with the shape that the lateral face is, a triangle. So I know that cross sections are a little bit confusing and I know it's really difficult to understand at first. So if you fall into that category of I'm really confused still, this link is actually super helpful. They do a great job of showing and visualizing the cross sections. So if you need more help, you can click on this link and view this. The only reason I did not show this is because it's honestly kind of boring. So it's only 3 minutes long, so as long as you can make it through those 3 minutes, they've got a lot of really good helpful like visuals that help you understand cross sections a little bit better. So if you have any more questions, you can email me though.